It's a little past 10. We had a little bit of technical issues, but we're going to go ahead and get started. My name is James Murphy. I'm a senior sales engineer here at Long, and we're here with another installment of the Long Coffee Break. Today, we're lucky enough to be joined by Tom Armstrong with Air2O and a few others that are going to be walking us through not only custom air handling, but custom engineering. So if you would please, Tom, take over and we'll go from there.
Excellent. Thank you, James. Appreciate it. So I'm just going to go ahead and launch because time is of the essence here. So we are a manufacturer of custom air handling, custom packaged equipment. And then our real specialty is we call it internally is hyper custom products and engineering. And where that really comes into play is when you just have that really difficult challenge that will generally involve some thermal transfer. It might be air, it might be water, it might be some other fluid, and a complicated solution surrounding that, or I should say problem surrounding that requires a highly engineered solution. And we'll show you a few examples of problems we've been able to tackle that I don't think you'd normally would associate with a custom air handler manufacturer. Our headquarters is in Phoenix. Most of our manufacturing is there, but we do have manufacturing around the world. And just to give you a sense of who we are backed by the renewable energies division of Total. That's the third or fourth largest oil company in the world out of France. So we've got a nice deep pockets investor behind us that is allowing us to bring the proper resources to bear on some of these challenges that you'll see. It's our new facility in Phoenix. We do have a UL 508 panel shop. So again, we are doing most of our manufacturing here. We can scale up into facilities overseas that are 500,000 square feet plus, and allows us to handle larger volume applications where that's applicable. Our self-description, if you would have asked us a few years ago who we are, we would have probably described ourselves as a manufacturer of evaporative cooling equipment and indirect direct evaporative cooling equipment. And that has really evolved over time as our engineering expertise has come into the forefront. Some of our customers have sort of dragged us into, and some engineers have dragged us into situations we hadn't anticipated, and we've been able to find solutions to some very, very difficult challenges. And so at this point, if you asked us who we are, we're really going to describe ourselves as an engineering company that also manufactures product. Our initial product that we entered the market with the US, into the US market was indirect direct evaporative and evaporative cooling products. We do think we make some of the best equipment in that niche in the market, and still makes up a significant portion of our day-to-day business. The key verticals that we're operating in now are in the cultivation vertical, data center vertical, and we have market experts for each of those verticals within the company. On the call, we actually have Tom Wellward, who heads up our data center group, as well as our chief engineer, Mo Salem, and we'll get Mo on here in a moment too. Other verticals where we're very active: dehumidification, the grocery stores and ice rinks. We've seen a lot of opportunity there, particularly since Munters has begun to focus more heavily on the data center market. It left a nice opening for us, and we've been picking up a lot of ice rink work there. We've also found opportunity for someone to simply supply a basic air handler at a reasonable time frame because of our manufacturing approach, where we partner with manufacturers around the world and facilities. We can scale up very quickly and provide a middle range air handler at a reasonable price in a short period of time. And that's we're just finding that there's a reception to that right now. But our real strength, as I mentioned, is the hyper custom products, and we'll talk about that further here, where there's almost no limits. We can do some pretty extraordinary things. And I'll show you examples, including where they required 0.01% relative humidity 24/7, or crypto coin mining modules with immersion cooled CPUs. So a little bit outside the range. Okay, this is what happens when you're not working on your home office. This graphic got screwed up a little bit. What you would see, if you could see this clearly, is a basic custom air handler, 55,000 CFM. That's it's what you would expect to see in a custom air handler. It's a box, it's got filters, it's got fans, it's got coils. And that is certainly one of the things that we can do. And the strength I think that we bring to the market right now in this place and time is that our lead times are better than most. We're in the 28 to 30 week range, even on some of the biggest equipment. For more standard stuff, we're in the 26 to 28 week. But we can also do some very, very highly optimized designs. And that's where Mo's team, their strength in the engineering, the depth of expertise we can bring adds to our ability. In this case, we really optimized the two tunnels. You can see they're uneven air tunnels. And we have in-house CFD capability. So we were able to do a very precise design on this and do a CFD model to determine whether it was going to be okay in terms of the pressure drops on that side that we were robbing a little bit of space from. The objective, of course, we want to maintain sub 500 feet per minute across the wheel on this particular air handler, but not sacrifice too much in terms of pressure drop on the other side. And the analysis showed us that we were at 0.01, 0.01 inches of static was all the loss. So it was a well worthwhile trade. There we go. And Mo, I'm going to ask you to jump in on this. This is one that we just shipped for the San Jose Sharks for their ice arena. And you can see, this is actually an earlier iteration showing a gas reheat. I think that came out towards the final stages, but we're using compressor heat for the regeneration of the wheels. Are you on there, Mo? Okay, maybe he's not. We'll just keep going. Smaller version.
I'm here, Tom. I'm sorry, my microphone was mute, so you can go back. Yeah. This is this is a quick dehumidification unit when we use the heat of the condenser to save into the gas heater that we needed. Later on, the design was revised, but this unit currently in operation with the Shark Arena. I believe it was either a 35 or a 40,000 CFM dehumidification unit, and we was able to go down with the dew point all the way down to like either 25 or 23, because they wanted maximum dew point in the space to be 40. So we have to supply dew point at 25 or 23. And this unit was doing cooling and dehumidification all in one. This one here, it's another dehumidification unit, and also using just the heat of the compressor to do a dehumidification. It does have a pre-cooling, post-cooling, and we use all the compressor's heat. And obviously, we do have additional condenser fan. We just kick it on to help the heat. This one here, it does have, it's a data center. It's up in Montreal. This is the largest data center per capita as far as how many server per room. We have, I believe, 12 rack or 14 rack, each one at 400 kW, total at a 5.4 megawatt. Yeah, 12.5 kW per rack for a 400 rack, I believe. So we have about 5.4 megawatt of cooling in a 5,000 square feet, which is the largest, the highest amount of megawatt per square feet per capita. This is another unit, which is SMR. I don't know what is the picture at, but it seems like to be cut.
Yeah, the picture got cut.
Yeah, this is a standard data center with economizer feature of a runaround coil. It's a 422 kW, 120 ton compressors. This unit shipped ready to go with everything from the factory. So there's no assembly on site. It come in two formation, either a parameter or a rooftop. This unit right here is also a heat, also a data center. This using a heat pipe economizer. That is the distribution of the airflow is different. This unit installed in Colorado, Denver, actually. This particular job, we have about 3 or 4 of them. Next time, I'm good. Yeah.
This is one that
yeah.
we'll just cover this real quickly. The objective here, very difficult objective, very small building. They wanted to, it's a biotech application. They wanted 100% outside air at 70 degrees and 0.01% relative humidity, 24/7. And you can see that that's a difficult challenge, requires multiple stages of desiccant wheels with DX cooling in between, or excuse me, heat recovery in between, because the air coming off the first wheel is too hot for the fans. So we have to cool it down before it gets to the fans and gets to the next wheels. So just a very, very difficult situation there. Another customer requested us to look at taking shipping containers and converting those into immersion cooled crypto coin modules. And so this is using Shell's single phase dielectric liquid with immersion cooled CPUs and a matching fluid cooling tower off to the side. And that's completely plug and play. You pipe them together, you plug in the power and the internet, and you're in the Bitcoin mining business. This is a project that's actually out. I'm in our Phoenix facility right now. It's actually out in the warehouse getting ready to ship the prototype. It's a gigantic vending machine for Walmart. And essentially you place your order for groceries online and drive up to it, punch in your code, and your grocery, all the wheels start turning, the racks start turning, your groceries appear. And we've designed, Mo's team designed the entire assembly, including the refrigeration, to keep all the food cool. And I think the key differentiator you'll find with Air2O is just the overall level of engineering. We have our own engineering tools, our DEN product, which interestingly, the DEN stands for Denver, because that was the first bin model data that we entered into the system, and somehow it got hooked into the coding. And if we try to change the name of the program, it actually changes it breaks the program. So it's going to be called DEN for a while. But it does performance predicting for energy and water, can calculate savings versus baseline, and we can determine the best cooling approach for a given project in a given part of the world, and compare whether it's DX cooling to IDEC to chilled water to DX, any other approach we want to look at, and determine hour by hour how close are we staying to the target temperatures for supply air and room air, and provide some basis for making decisions. We have already online one iteration of that specifically for the cultivation vertical. As I mentioned, we're very active in cultivation. And so you can go to growcalc.air2o.com and sign up for an account there, and we can let you in there at your convenience. And then the last thing we want to show you, again, this is something that most team has deep capability internally. We'll do this for our own projects. We'll do a CFD analysis when it makes sense. In this case, we're showing a coil that had discharge at an odd angle, and we just wanted to make sure that we didn't have any dead spots where air was going to not be circulating correctly and moving on out into the system. But we can also offer this as a service through your rep at Long for whole facilities. So if it's a data center, we would just need to know the kilowatts per rack. We would need to know the CFM per rack, And then of course the plans for the building. We can do a full CFD for the whole building as a service. We can do the same thing for cultivation projects or really any other kind of project. We just need to know all the parameters going into that. But at any rate, that's something that's available that a lot more demand for that we're finding in the marketplace, and not that many firms so far are offering that. So we can simply offer that as a service. And I think that's basically it for us on here.
Join us next week on the coffee break with Devin Gash with Venting Made Easy. I really appreciate everyone for showing up. Thanks, Tom and Mo, and we'll talk to you all soon. Thanks.
Thank you very much.